Good afternoon, everyone. I'd like to say thank you to MINDS to invite me as a speaker for this National Women Conference. Today, it's my pleasure to share with you my journey as a woman engineer throughout my past 10 years to now. Today, I would like to share about women engineers in era 4.0. I believe that everyone in this room, we are experiencing the new norm due to the COVID-19 pandemic. The new word right now we use is online shopping, online classes, online meetings. We have online food delivery and so on. The way we work will never be the same again. The skill that we had and we need will be different dramatically. For example, since last year MCO, right, I have to retrain myself to have the skill to teach online. So nowadays, it's a new word called hybrid. I have to teach the class through physical class and at the same time, online class. That's why the word hybrid has come. So this COVID-19 is actually has accelerated era 4.0. Later I'll show you a slide. What does it mean by Industrial Revolution 4.0? As you see over here, Industrial 4.0 has enabled us to work online, to enable us to connect with people even from far away, from the US, from Europe. It does not have a matter as long as we have this platform such as Zoom, MS Team to enable us to connect to our peers and colleagues. There was a survey done by McKinsey. These surveys were, the respondents are from the global manufacturing leaders. 94% says that era 4.0 has helped them in running their operations tremendously. And another 56% says that era 4.0 is very critical for their crisis responses. Therefore, ladies and gentlemen, what is this era 4.0 is all about? As you see over here, this is a chart, the industrial revolution from 1.0 until today we are in the industrial 4.0. Let me straight go to industry 3.0. Industry 3.0 is about digitizations, where at that time, the world, 1969, everyone is talking about automations. We want to have reduced the labor intensive so that we use machines to help us to do the jobs. But now we are in the era of Industry 4.0 where we want to have these digital transformations. Digital transformations where right now I think everyone else heard about these words, the terms called smart homes, smart cities, and as well as smart manufacturing line. In fact, this smart manufacturing line is very suits into this Industry 4.0. So what does it mean by smart? Industry 3.0 enables to have this automated system. However, in these digital transformations, it enable the machines to talk to each other, enable the machines to analyze and give a feedback to you saying that they are not healthy. So it's enabled to let the machine to have a self-monitoring, for example. So what are the pillars that enable these digital transformations? There are total 9 pillars. Over here, autonomous robots, cloud computing, big data, system integrations, 3D printer, IoT, augmented reality, simulations, and the cybersecurity. Of course, I cannot go into details for each one of these, but let me give you 3C over here at the center of this diagram here. The 3C are communications, control, and computations. It is the backbone for this era 4.0 concept, whereby communications about how do we interact with each other, the connectivity. I'm sure everyone here, if let's say, if there is no Wi-Fi connection at home, right, or in the office, or anywhere in the outside the restaurant, we will like, oh, what should I do right now? Because we don't have internet, we cannot surf Facebook, we cannot do our work. So the connectivity is so important, and whereby this Internet of Things plays under these communications. we need to let the machine to talk to each other. This control is about interfacing. We interface various of sensors. There are many types of sensors outside depending on our applications, such as temperature sensors, for example, to sense the temperatures of our air conditioning systems. Imagine one day your air conditioning systems give you a alert in your phone, say beep beep, yeah, it's time to do the service. How good it is, right? We do not need to wait for an aircon breakdown, or it's not cold, then we call the technicians. But it's already give you a hint that the gas inside the aircon is almost flat already. We need to do the service. Yeah. So if you ask me, right, this digital transformations is all about computation. Computations in terms of the big data. This era is about big data. The new term you heard about, right, is data science, right? Data science is about how do we analyze the data. It's all about data implementations. Yeah. If let's say you can analyze the big chunk of data and crunch them and become the useful data to make something useful, to analyze something useful, to give you a better solution, yes, this is about IR 4.0. Yeah. And among all these things, right, without IC semiconductor innovations, if you're not able to happen so successful. What's the reasons? It's because IC semiconductors is the backbone for all these systems. Why do I say so? I will let you know in a few more slides. Okay, before that, I would like to bring you to this history of our E&E industry in Malaysia. Yeah, it's all started since 1972 in Penang at the Bayan Lepas Free Trade Zone or Free Industry Zone. Yeah, over here in Penang here, if you drive your car to Bayan Lepas, you can see many gigantic factories. For example, MNC companies such as Intel, Altera, Broadcoms, Robert Bosch, Osram, and so on are here. Yeah. In fact, Intel technologies have total, in my time, there are 12 buildings that belongs to Intel technologies. So I would like to let you all know, E&E industry in Malaysia has grown up so much, and it has grown up by leaps and bounds. Yeah. Why? Let me show you this data. This data is from the source of Matrix 2019. It shows the total export of the products from Malaysia. All right, and you see the big chunk over here. Electrical and electronic products export has become the biggest chunk, which is the total of 37.78% of this total exports. So you can see that E&E industry has contributed so much into Malaysia's development right now. So it's continued to grow strong. There is a huge demand. Why? It's because of the recent last year, right? Everyone know about the US trade war with China, and it has pushed, right, some of the foreign investments come to Malaysia. Especially now, you will see there are investments. Yeah, they invest at the Batu Kawan in the Seberang Pride area. So it's going to be more and more exciting, and it's going to grow stronger and stronger. All right, let me share with you my career journey in semiconductors. How many of you here in this room does not have a phone? Yeah, in this picture is a phone, yeah, of an Apple phone, the latest model. If you tear down this phone, right, actually besides the battery, you will see there is a lot of black color electronic component. It is a IC chip. Yes, IC chips. And my job for the past 10 years, I deal with chips. It's not potato chips, but IC chips. Yeah, and IC chips stand for integrated circuits. Inside these integrated circuits, there are billions of transistors, especially microprocessors. Yeah, is nowadays, right, the technology node has so small until about 5 nanometers. Yeah, it's nanometers. It's now we are in the nanotechnologies. Yeah, and semiconductor is at the pioneer for this complex technology. Yeah, this is an overview here of my career journey. I started as a technician in Agilent Technologies. Then I moved to Intel Technologies as the system validation engineers in validate the microprocessor, new silicons. Then I moved to Freescale Semiconductors to perform the to take care of the products. My products are microcontrollers. Then after 4 years, I left. Then I had a full-time research as an enhanced packaging, yeah, and researcher. Then here I am right now as a university, as a lecturer in UCSI, University Malaysia. Yeah, this is my brief of my career journey. Yeah, I would like to share with you, yeah, ICs consist of many process, from the IC design to wafer fabrications, then from wafer fabrications to assembly process, to final testing, and before it shipped to customers. What is this all about? Okay, let me give you a scenario. For example, today, customers want to have a special specifications that functions, for example, to have a higher speed or higher RAM size. Yeah, then our design engineer will take you on this and come up with a new circuit design. From the circuit design, it turn into a layout designs. Layout design, there are many layers of this digital circuits, and then from there, once we finalize, yeah, the design engineer will come up with a mask. Yeah, this mask will send to the wafer fab, and wafer fab will fabricate this wafer. Yeah, either it's a 12-inch wafer, 8-inch wafer, or some are 4-inch wafer. Yeah, and for your information, this wafer fabrication is the most expensive process. That is why some of the semiconductor manufacturer, right, they do not prefer to own this process. They will outsource it, for example, to the giant, yeah, in Taiwan, TSMC, yeah, to do the wafer fabrications, and then we get the wafer, we perform our own assembly process. So my journey is here, the assembly process and final testing. Yeah, assembly process is to, once we get the wafer, we perform soldering, die attach, the interconnections such as wire bonding or flip chips. Then we go for the encapsulations, yeah, to protect the inner die before go for final testing. Final testing means it's very final to make sure that our IC chips are good products, and we ship to customers. So at this slide, I would like to share, the role of a product engineers. What I did, when I was a product engineer. In fact, right now, the role of a product engineer did not change. Yeah, it's still the same. Our ultimate KPI is we need to increase the quality of the product with minimum cost. We want to have the higher the better of the productivity with reduced cost. That is why we always have productivity quality increase with the lower cost. Yeah, in this picture, right, why I show this one is because that during my time as a product engineer, I deal with automotive customers. Automotive customers, they have a higher spec because it's about these IC chips, right? It's put into our car. Imagine your car, Honda car, your Toyota car, right? The brake systems must be good to ensure that we are safe. The safety is the utmost priority from our customers. Therefore, the reliability of these IC chips in a car is the number one priority by the customers. Yeah, we are buying according to the AEC specs, which is the Automotive Engineering Council. Make sure the reliability of the chips is good. Yeah. Do you know that I just read an article? Yeah, the car nowadays, right, consume 30% of the entire cost of a car. You can imagine how many IC chips that control a car or the different functions of the car. For example, the powertrain, vehicle dynamics, and the window control, the engines control, the body control, yeah, the brake system control, and many more. Yeah, and recently, right, it shows that, especially from Tesla, yeah, innovation in semiconductor industry are driving the next generations of EV, means electric vehicles and autonomous vehicles. It's such a disruptive in these technologies. I also watched a video, yeah, from China that they has really already implement autonomous vehicles, yeah. It is so high-tech technologies. So Malaysians, are we ready? Yeah. Okay, let me share my career journey when I was in assembly process. Yeah, this is the IC chips that I showed you just now with the encapsulated mold compound. Now, if let's say we do the decapping that is to remove this mold compound, right? You will see this inner die. Yeah, this inner die. Yeah, if you see this wire in gold color, actually they are gold wire. Okay, they are gold wire. So therefore, what is this interconnection technologies is all about? It is a method for electrical interconnection between the internal silicon chips to the external world, such as when you solder it to a PCB board. So this process need high speed, high accuracy, and high precision because we are no longer dealing with big size, but we're dealing with fine pitch micron size. Yeah, this video, right? Let me show you this video first. Yes, this is the actual wire bonding process when I did the wire bonding during my time as a researcher. Yeah, uh, these videos is in fact is actually captured through a microscope. It because that the die is just as big as our new size only, and then the wire bond, the wires is in fact is very fine pitch up to 2018 micron size. And this is a tweezer. This tweezer, sorry, not tweezer. This is a capillary. Yeah, the capillary you need to use a tweezer to hold it. You can imagine the tweezer to hold it is a very small needle, yeah, to do this wire bonding. And this wire bonding process is the most complicated assembly process. Yeah. Over here, I would like to share with you about my PhD research. I did process optimization and reliability studies on this 20 micron fine pitch insulated copper wire bonding. The novelty of this project, the research is all about the wire. This wire has a thin layer, organic coating, which is the thickness is about 100 nanometer only. Yeah, 100 nanometer is very thin. Yeah, you want to study whether this wire, yeah, is reliable and is the bondability of this wire is good or not. So at the end of my 4 years research, I was able to file a patent together with my colleagues at that time, yeah, my peers. Yeah, this patents called wire bonding apparatus and method. Yeah, sometimes everyone, ladies and gentlemen, I think that when we have a problem, we do not need to be afraid because the problem sometimes will lead us to another success. So this is success that these patents, right, is about the novelty about polishers as concept, an idea that I put a intelligent polisher at the wire bonding system to polish away the insulations. Yeah. So what is IRA 1.0? What is smart manufacturing line? Yeah. So how can we achieve a excellent manufacturing line with IRA 4.0? So the manufacturers and the suppliers, they work together hand in hand, yeah, to implement real-time process and performance monitoring, real-time equipment health monitoring, and for example, and of course, it can't run away, as I mentioned earlier, the advanced data analytic and traceability. We must able to trace, yeah, about our process from which lot, from which month. Yeah, this is very important. Yeah, from which machines and who was operator that operate that machines. Everything must be documented and must be traceable. Yeah. Of course, the last one is about predictive maintenance monitoring analysis. Yeah. So let me give you a scenario about this. If let's say we have this manufacturing excellence, right, where we can have a real-time monitoring through a dashboard, we can save a lot of our time. For example, I'm sure everyone see this photo that I'm wearing these jumpsuits. Yeah. So when I go to assembly floor, from office to the assembly floor, it takes about 5 minutes because the factory is big. I need to take leave, go up and go down to reach the assembly floor. At the assembly floor, it takes me about 10 minutes time to change my attire, full attire. Yeah, you only can see my eye, boots, hairnet with the glove and with the mask. Yeah, takes about 10 minutes. And before you really go into the production floor, you need to go to a shower room. Yeah, clean room. Before the clean room, there's a shower, air shower to shower away all your contaminants, your dust. Yeah, before you can execute the task. So the lead time wasted, yeah, go and forth, right, is about 30 minutes. And this 30 minutes can be saved if let's say we have a real-time monitoring whereby you can control the system by a few clicks and the job gets done, right now. Yeah. So this is I got it from the internet. So basically what is smart manufacturing with IR 4.0? It's about faster response to the production needs. Yeah. And it's a much greater efficiency by a real-time monitoring and by a few clicks and controls about what we can see in the dashboard interface. This is what we want with the smart manufacturing with IR 4.0. So at the this is almost the last slide. In my opinions, right, to make the IR 4.0 integration successful, each stakeholders must play their roles. Yeah, industries, government agencies, and the academia. Yeah, in terms of the academias, right, I would say that we as academicians, we have the role, to prepare my graduates. They are fully equipped with this IR 4.0 knowledge. Therefore, my research projects and most of it are industrial collaborations. Is one of the projects is energy meter monitoring systems with the IoT systems. So I always active in the NGO and try to have this industrial collaboration because industry have the real problem. Yeah, I can use the case study and let my student to perform the research, and after that they have the experience, they have this knowledge and skills that the industry want. So I'd like to end these presentations with these slides. Yeah, who are engineers? Engineers is a team of professionals, a team that we work together to solve problems. We are the problem solvers. Yeah, we are fun, but when we work very hard. We are dynamic, and we are here to contribute innovations to the national developments. So to the students, if let's say you have this kind of characters and you like to join as engineers, please come because now is the time. Engineering is booming again. Okay. With that, I would like to end my presentations. Thank you very much.